Today, our lesson will be centered on the tree diagrams, which will be applicable to both grade 11s and also grade 12s. Without wasting any time, let's go straight to our lesson. So first of all, you must always remember that the tree diagrams are very, very important whenever we're given different possible outcomes of different events. So whenever you're given different events occurring at once, it's always advisable that you must use the tree diagrams. You can also use the Venn diagram, which we'll do in another video. So please check our playlist where we're going to be covering all the content that you need to know in grade 11 and also grade 12. So whenever you are given different possible outcomes, always try to use the tree diagrams. So let's do a quick example to show you guys how you can use the tree diagrams. Let's say we have got Thabo who was given a bank, and then let's just draw that bank. Let's say our bank, that's our bank there, or inside yeah, that's our bank there. So inside the bank, we have been told that we've got 4 oranges. Let me try to use the orange color. We've got 4 oranges inside. That's, let's say, orange number 1 somewhere there, orange number 2 somewhere there, orange number 3 there, and orange number 4. So we've got 4 oranges inside, and also we've got 3 apples inside. I'll just use a bit yellowish for apples. Yeah. So we've got 3 apples also inside. So our bag has got those 7 fruits, right? We've got 4 oranges and 3 apples. They are all in Tabo's bag. So if Tabo picks a fruit at random, then you need to calculate the possibilities of him picking up O, which represent orange, and then A, which represent apples. So now we need to go and do those different possible outcomes. So first thing that you must do is to do what you call a first generation branch. So the branch will be something like this. Just go and put a branch. This will be a first generation branch, like that, like a less than sign. So on this first branch, you must go and represent where you're going to put your oranges, for example. We were using oranges as O, so I'm going to put O there to show that that line there is for orange, and then I'm going to put A there to show that that line is for apples. So we know originally we were having 4 oranges. So we've got 4 oranges in Tabo's bag. And then out of how many fruits inside? We've got 7 fruits inside. Because we've got 7 fruits inside. We have 4 oranges, but we have got 7 fruits inside. So, and also we know we're given 3 apples out of how many fruits? 7. So this will be your first generation or your first branch of the tree. Then from there onwards, if, you need to be careful now, if Tabo picks an let's say he picks up an orange, because remember he's picking up fruits at random. It can be any fruit inside. So just putting his hand inside, and it can be any fruit inside. So if he picks up orange, therefore if he takes that orange in this bag, just trying to represent here, if Tabo takes the orange, let's say take this orange out, therefore the orange will be gone now. Remember initially we had 4 oranges, meaning now we'll be left with how many oranges? 3, because he's taken out 1 orange from the bag. Maybe he ate it, or maybe he threw it away. So for practice sake, let's say he takes out the orange, then he holds it outside. So that will be the first event happening. He will take the orange, then he will hold it outside. So the event of that occurring means that 3 oranges will be remaining inside. Now because he has taken out 1 orange in the bag, that means 6 fruits will remain inside, because he's taken out 1 orange. This means 6 fruits are gonna remain because 1 orange has been taken out. So meaning 6 fruits must remain. That is for orange, right? So I'm gonna put this one as orange because I'm focusing there only for oranges. But remember, there are 2 things in the bag: oranges and also apples. So if you took out an orange out, let's say I'm gonna call this one orange just to show that he's taking out orange here. Orange, just called orange just so that he's taking out orange. So if orange is being taken out, that means that the apples will remain the same as 3 because an orange was taken out, meaning the apples must remain the same, because here I'm putting in apple, so meaning apples will remain the same. But how many fruits are remaining inside? 6, because I've taken out 1 orange, meaning 6 fruits will remain inside. but apples will remain as 3 because I didn't take any apple out. Sharp. Now let's say down here, now he's taking out an apple. Remember, either you can take out orange or apple. Let's say now he's taking out an apple. So I'm gonna have a branch for that as well. Let's say on this branch, I'm representing, okay, I'm trying to remove this here, that doesn't confuse you guys. Let's say on the lower branch here, this is the event of him taking out an apple. Remember, we're at random. You could have either taken an orange or an apple. Here on the first instance, it was when he took out an orange. Now on the second instance, let's say he took out an apple instead of an orange. Let's say we are back to normal. We've got 7 fruits inside, but he took out an apple this time around. So if you were to take out an apple instead of an orange, we know that oranges won't be affected, meaning oranges would have remained the same as 4 if you're taking out an apple. But then if an apple was taken out, meaning it will remain over 6 because 1 apple was taken out, meaning the fruits will decrease. But orange won't be disturbed because it took out an apple. Now, because an apple was taken out, now this means that the apples who will remain inside will be 2 out of how many fruits inside? 6. Just be careful of such there. Here, it's when he took out an orange. Here, it's when he took out an apple. Remember, any could have happened in random. If an apple is taken out, orange won't be affected. But if an apple is taken out, if an orange is taken out, therefore apples won't be affected. So this will be a tree diagram which will be representing the 2 ways in which Tabo can pick up a fruit. And please don't get confused by saying, no, but an orange was taken out before. No, that was a possibility of an orange being taken out. So whenever you do the second one here, don't take into account what happened in the previous one, unless you were told so. Okay. So remember, now they're asking us to find the probability of O. So remember, this is your first O that you have here. And then our second O is this one. So it's going to be OO. So it's this O here and this O, they're multiplied by each other. So meaning to get the answer, you just go and do 4/7. And then you multiply that by the other one, which is 3/6. So that will be your answer for the first one, 3/6. Okay. So, and then, so meaning your answer will just come back as 4 times 3, that's 12. So it will come back as 12/42. So our answer here will be 12/42, which you can put also as decimal if you want. That'll be the first one. Second one, remember now it's apple and apple. Our first A is this one here. That's our first A there. Then our second A is this one. Remember, focus only with this in A. You can't use A and O here. No, because we want A and A. So you must focus only when this A. So our first A there is 3/7. And then you multiply that with our second A, which is 2/6. And then again, our answer will come back as 6/42 as our answer. So that will be our answer for OO and also AA. So if maybe they'd ask us to find the probability of OA, for example, if it was OA, for example, OA would have been this O here and that A there, plus that A there and that O there. So you would have added the 2 products to give you the OA and also AO, which will come back as the same answer. So that will be that with this example, which I hope that it will help you guys a lot. If not, please comment on the comment section, then I will assist where I can assist. And then let's just try one more example. On this one, it's a bit of a different one, but still the same concept will apply. So we have been told that there are this one I got it from a past paper. So I've been told that there's a group of people who are participating in a trial test for a new headache pill. Okay, 50% of the people received a headache pill, and then 50% of them received the sugar pill. 2 of the group receiving the head pill were not cured, so they were not cured. These ones, just be careful. If 2/5 are not cured, this means 3/5 must be cured, because remember it's out of 5. So meaning if 2/5 is not cured, 3/5 must be cured. 3/10 of the people receiving the sugar pill were cured, meaning sorry, 7 over 10 won't be queued because they work inverse. At the end of the day, when you add them, they must add up to 10. So if 2 over 5 is not queued, therefore 3 over 5 will be queued. Same, if 3 over 10 is it's queued, therefore 7 over 10 will not be queued. So now they're asking us to represent that in a tree diagram. Okay, first thing first, remember you always put the first generation. So you must always put the first generation. So the first generation is what we're given at the beginning. We're being told that there were people who have been tested for a sugar pill and also a headache pill. So you must ask yourself now, which letters are we going to use? Let's say you're going to use H for the headache pill. So H is for headache pill, and then we're going to use S for sugar pill. So we're going to use H for head, and then S for sugar, just to at least have a good letters. So we're going to use H for head and then S for sugar. So here I'm going to have a first part of the branch for head, second one for sugar. Then remember, we know that the people who were using head were either queued or not queued. So for head, we're either queued, which is I'm gonna use C, not queued, I'm gonna use NC. Those are for the ones who are either queued or not queued. Same thing applies for the ones who use sugar. I'm gonna put a branch there as well. They were either queued or not queued. So this will be your two different events that were given on the statement. Now let's put the values. We're told that 50% of them received a headache, so meaning it's gonna be 50 over 100. That's 50 over 100. So it'll be 50 over 100 as it's 50%, 50 over 100. Same thing here, it's also 50 over 100 based on what's given to us. And then from there onwards, we are being told that the ones who are on headache, 2 over 5 were not queued, which is this one here. So 2 over 5 are not queued for those ones in headache. 2 over 5 are not queued, meaning 3 over 5 must be queued because we use the overall number of 5 there. If it's 2 over 5, therefore the other one will be 3 over 5. And then we're being told for the ones in sugar pill that 3 over 10 are queued. So for sugar, queued is here. So it's 3 over 10. We're being told that 3 over 10 are queued, meaning 7 over 10 will not be queued for the ones in headache. And then that will be that. That will be full for 3 marks. Yeah, should give it 3 marks because you've put all the information as was requested on us. So that will be that. That will give you 3 marks for this first question here. That's that. So now, for second question, we need to check what they're asking. They want us to find the probability that a person chosen at random from the group will not be queued. So they want us to find the possibility of a person who will not be queued. So we need to check whether are the not queued ones. We've got one there, not queued there, and also not queued is there. So remember, we start here. So for us to have someone be not queued, they can either be on a headache pill, which is H, and not queued. So it will be H and C first, plus the second one, which will be sugar, not queued, because it can either be from headache or also from sugar pill. So now we know from there onwards, headache, we know it was 50 over 100, the first branch here, this one for headache, and then we're going to go to this one. So the headache is 50 over 100, and then you multiply that with not queued, which is 2 over 5. And then remember, if you're doing those mixtures, you must add them. So we're going to add that with sugar. Also at the beginning, sugar was 50 over 100, and then you multiply that with not queued, which we know it's 7 over 10. So and then you just go and add the values as they are. That will be our answer. So 50 over that times that. So 50 over 100 times 2 over 5 plus 50 over 100 times 7 over 10. Okay, that is 11 over 20. It's a nice connection. 11 over 20 when it's simplified. Or you can use decimal if you want. Either way, still fine. Decimal, it's giving me 0.55. So that will be that. That will be that. So that will be your answer for that. And then that will be all for tree diagrams. And again, please check our playlist. We'll be doing a lot of other examples that at least we can prepare you guys for September tests and also final exams in November. Thank you very much, and please don't forget to subscribe, like, and share, and comment as well.